trying to find the tangent line, and they give us the tangent of x, and it's at x is equal to pi over 4. So anytime you're coming up with a line, you know that it's going to be in y minus y1 equals m times x minus x1. Now, again, to the left and to the right of the equal sign, we're going to have a very, very similar process. To the left, what we're going to be working with is our f of x function. So f of x is tangent x, and then we're going to plug in x is equal to pi over 4. And so that's going to give us tangent of pi over 4. And if this is not 100% clear to you, what you would do is you would convert tangent into sine over cosine, and then you would look at your unit circle, and on your cute little unit circle at pi over 4, we have the square root of 2 over 2, square root of 2 over 2. So what would happen is the sine of pi over 4 would be the square root of 2 over 2, and the cosine would also be the square root of 2 over 2. So that would just give you 1 for your f of pi over 4 answer. So that would go for your y1. Now, remember that on the right-hand side, you're going to be doing the same process, just with the derivative. So you're going to find your derivative. So the derivative of tangent, remember you need 1 tangent and 2 secants. So you have the 1 tangent, so you need 2 secants. And then just like we plugged in x is equal to 4, over here we're going to plug, or pi over 4, we're going to plug in x is equal to pi over 4. So our second step is we're going to look at f prime of pi over 4, and that's going to give us, now here, I mean, some people can look at this and know what it is, but I think like a lot of times in trig, like what they did is they converted the secant into 1 over cosine squared pi over 4. So the cosine, and remember that this, and maybe I'm making a mountain out of a molehill, but remember that this is the same thing as cosine of pi over 4 quantity squared. So what you are looking at here is you are looking at 1 over the cosine of pi over 4 square root of 2 over 2 squared. So if you square this, you're going to have 1 over the square root of 2 squared is 2, and then 2 squared would give you 4. So because you have this complex fraction, you would flip this denominator, and you would get 4 over 2, which would just give you 2. So that would be your f prime evaluated at pi over 4. So putting this together, what would happen is you would have y minus your y1 coordinate, which is 1, equals your derivative evaluated at pi over 4, which gave us 2, and then times x minus our x1 coordinate, which was pi over 4. And you could leave it like that, or you could solve for y and get it into slope-intercept form.